Welcome to this problem on direct proof, a key skill in math. We need to prove that the sum of the squares of any even number and any odd number is never divisible by 2. First, let's define our terms. An even number can always be written in the form 2n, where n is any integer. An odd number can be written as 2m plus 1 or 2m minus 1, where m is any integer. Now, we use different variables n and m because the numbers do not have to be related. Now, let's set up the expression based on the problem. We need the sum of their squares, which is 2n all squared plus 2n plus 1 all squared. Let's expand this. 2n squared gives us 4n squared. Expanding 2m plus 1 all squared, this will give us 4m squared plus 4m plus 1. Our goal is to check for divisibility by 2. Now, let's see if we can factor out a 2 from this expression. Looking at the first three terms, they all share a common factor of 2. Factoring this out, we get 2 times the quantity 2n squared plus 2m squared plus 2m, all plus 1. Now, think about the expression inside the brackets. Since n and m are integers, squaring them, multiplying by other integers, and adding them together will always result in another integer. So let's call this integer k. By substituting k, our entire expression simplifies to the form 2k plus 1. This is the very definition of an odd number. Now, since our result 2k plus 1 is always odd, it can never be evenly divided by 2. So we have successfully proven the original statement. In this example, we need to show that the expression x plus 2 squared minus x minus 2 squared is equivalent to 8x. This means it's true for all values of x. Let's explore two ways to prove this. Now, method 1 is direct expansion. We'll start with the more complex left-hand side, or LHS for short. Now first, x plus 2 squared expands to x squared plus 4x plus 4. Next, x minus 2 all squared expands to x squared minus 4x plus 4. Now we're placing these back into the expression. Now be careful here. A common mistake is forgetting that you are subtracting the entire second bracket. So we must distribute the negative sign. So without using brackets here, your answer will definitely be incorrect. So we must distribute the negative sign to each term inside the second parenthesis. This gives us x squared plus 4x plus 4 minus x squared plus 4x and minus 4. Now, we can simplify by collecting like terms. The x squared and the negative x squared, they cancel out. The positive 4 and the negative 4, they also cancel out. Now we are left with 4x plus 4x, which is equal to 8x. This matches the right-hand side, so the identity is proven. Now for a more elegant approach, perfect for saving time on the exam, notice that the structure is 1 squared minus another squared. This is the difference of two squares. So from the formula booklet, we know that a squared minus b squared is equal to a minus b into a plus b. Here, a is x plus 2 and b is x minus 2. Substituting into the formula gives us x plus 2 minus x minus 2 times x plus 2 plus x minus 2. We simplify the first bracket to get x minus x is 0 and 2 minus negative 2 is 4. In the second bracket, x plus x is 2x and 2 minus 2 is 0. So we are left with 4 times 2x, which is 8x. Much faster, both methods work, but recognizing patterns like this is a fantastic skill and will save you a lot of time.